Okay, today's session I will continue talking about our client server model. In particular, I will do the read, write from socket. I'll do reading from socket, I'll do writing into socket, and of course the complete picture of Echo Server. We have seen how we can create a socket, how does the server accept it, and what are the issues involved in creating sockets on both client and server. So going back to the IPC descriptor, which is IPC means inter-process communicator, and this is between the sockets on the client and the server. So remember that sockets serve as an interface. It's the point of entry between clients and server. That's how the clients and server communicate using the inter-process communication. So we did the creation of socket, which is using the new socket method in a class. Now we want to do, once I have a socket created, I should be able first to write into the socket, and once I write, I should be able to read from the socket. Okay, and also I should be able to destroy. So these are the three major operations. So one more time, let me write them for you here. We use this insert from shapes. The three major issues in a socket. Oops. So this is first create a socket, then write into a socket, read from a socket, and finally destroy a socket. Why do I need to destroy a socket? Because I don't want to leave a socket open behind me so that no intruders can come into the socket. So let me just make this bold. So these are the major operations that we have on sockets. Okay. Now, and of course we use certain protocol, which is we will use the TCP protocol. There is the other one, UDP. I will do at least one exercise on UDP, but for now I will continue using the TCP transport protocol, transport control protocol. UDP stands for unreliable or unigram data protocol. And the sockets, we said they are identified explicitly by the port address, and the port address is remember the port address. Let me remind you one more time. Let's put it here. Port address is 16 bits, which means that we have a total of 2 to the power 2 to the power 16. Oops. How do I do this? Control anyway. To the power 16 total addresses. Those are the number of addresses we have, which is roughly 65,535. This is number of ports. So we identify it by an IP address or the local host. Local host is whenever the address of the client and the server both are on the same machine, and there is a port number which I said it's one out of these 65534 different addresses. Okay, now as I said, we have already known how do I open a socket using the class socket and the method new, or create a socket and then use connect. Now let's see how we create an input stream. Input stream, usually we have two things. Let me again try to do that so that, whoops, okay, one more time, let's try this. Okay, so I have input and output stream. The input is used to read from socket, and the output is used to write into a socket. Now remember, when I say read write, I want to visualize the socket as follows. Let me show what I want to do here. Okay, let me just put a new slide altogether. This is, I will call this is my memory, and there is a portion of the memory, okay, a portion of the memory this portion, let me color it with let me color this with this portion of the memory. I will call it my ports or sockets. And where do I want to put this up in my and here there are, as I said, 65,535 entries, and entry number 1, this is entry number 1 here, 000 1 2 3 4, that's 8 1 2 3 4 12 1 2 3 4 16. This is address number 1, first address. The last address is right here, and there are 16 ones here, 1 2 3 4 4 1 2 3 4 1 2 3 4. So from zeros, 16 zeros to 16 ones. So from 0 all the way to 65 535. These are my ports. Now let me do my client here one more time. This is my client. Okay, and I create what I call a socket. Let me give the socket this color. Okay, now this socket will have a pointer which points somewhere here, and assume that what I write in the socket the number 12028. The reason I put 2028, I just wanted this to be easy to remember. In terms of binary, this number will look like this. Actually, I think 10. What's the 12028? So if I have 18489, something like this, this will be 1024. If I multiply this by 2, this will be actually okay. So that's where it will point to this number right here in the addresses. That's how my memory. Now when I say I want to write into the socket, say write into socket, actually this right here, it is something like this. So I want to write into the socket. So I come to address 2024. This 2028 will take me to this location, and I will write here something into this location. And let me take this location. So I'm writing here. Let's say I want to write something here. My name is X. So when I want to write into the socket, and I will show the method, I will say write into this socket whose address is 2028. The 2028 is one of those port numbers. So this is the memory location pointed at by the 2028. I write something. I want to write my name is X. Now I want to show something more, probably you already know, so that you don't have to argue with me, and you will tell me, well, Professor, this memory location is only 1 byte. How do you write the my name is X? Well, my name is X would be 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, and each character takes 1 byte of memory. So really, in reality, what you will do, you will write it consecutively here into these locations, and something like this. So it will be my name is X will be written all over 1 byte by 1 byte. So actually it will be first character will go here, and the last character X will be here. So this will be will be my name is X, something like this will be. Let me take this down so that's how it will be. So it will be something like this. But this is exactly, so I'm writing, this is my socket, and this is my output stream. I write into 2028. 2028, this becomes an address like this. 56011, then all zeros. So I find this location, and if I am writing into 7, my name is X, has 7 characters, I will occupy these 7 places and I write into them. So this becomes, and again, if I really want to be more accurate in terms of, because these locations are reserved for ports, so that will not be this is the socket data, and this will be will point down here, because you don't want to take the data which is reserved for the port numbers and write into them, so we will defeat our purpose. So I get this, my port number get me here, and this is a pointer to where the data will be written. So if I want to read the data which was written into the socket, I will come to 2028, this is 2028, I will find a pointer here, pointer to socket data. So this pointer to socket data will point me and I will be able to read it. Okay. So having said that, this is a very interesting picture. Let me go back now a bit more detail. How do I create an input and output stream on both server and client? I have just described the issue for the writing. The reading, the read from socket, let's take it this way, read from socket will be in a similar manner, but it's reversed, so it comes this way. Let me choose another one. This guy is much better. Okay, so the reading, I am reading from the socket, which is 2028. I go to this pointer, I find this data, I read it, and I take it to this location here. Okay, how do we do that? And this you will do it in the lab session. So you will, now on the server side, you can use, so we have on the server side, and the same thing will be on the, we use different classes. Let's say class called data input stream, or actually we use the data input stream to read, to receive data from the client. This is the class data input stream we define. This is a Java already defined by us. You can actually write it exactly as is, and you define your variable input. Now note that this is a variable which you define, you can, let me use this, you can use, instead of input, you can use x, you can use value, you can use any variable. So this is any variable you can use here instead of input. This is user defined variable. And then use the try catch. Try catch is, this is, you already learned that, so that in case you could not read from the socket. So assuming that now here your input, you use the input which you have just defined it in the following manner. Remember that your input is of type data input stream. So input is a new data input stream. So you define this input is a new data input stream, and you associate this input with a server socket. Server socket, this is your server. This is the socket you created on the server side. So you say a new data input stream. This data input stream is going to read to read from this socket, and assuming that I call this socket what did I call it here? Or server socket or service socket. So this is my service socket. And so this is my service socket, which which has this port number. So I use this input is a new data input stream defined on service socket, and then I use this method get input stream. Get input stream means read whatever is in the socket. This is the port number. I find this port and I find it valid, and I'll take this pointer and I go find the data which is here. I read them and make an input stream coming from these values. Read from socket. Actually, let me define this as my input. So my input stream starts coming from here. No. Starting from, let me do something more, something like this. Okay, so from here I start reading into this input stream. I made this messy, but I will clean it up in a second. So get input stream, it starts reading from that input all the way to from the memory locations defined by the port number 2024, having an input stream coming into the variable input which I had just defined it. In case, what happens in case the socket was closed? I couldn't find the 2024, somebody has closed it. Well, I catch this error as an IO exception and I print there is an error. What happens if the data here if this memory was corrupt. There is a problem with this memory. There is a memory corruption. Again, I will do the exception. Okay. Now, creating an output stream on the client side. Again, here I introduce the print stream. Oh, wait a second. Output stream on a server. This is input stream on a server. Where is my input stream on a client? Looks like actually this input stream data can be both on a client and a server. Let me duplicate it so we don't get confused. Create an input stream on a client. The only thing is you can do data input stream. You call it, I don't want to call it input, I want to call it client input, just to make sure that we really, you can use X value and anything. So let me, I don't need this. You can use anything, but I use client input. Input here new data input stream, and here you just write the my client. I think in the echo server we defined our socket as my client. No, the only difference is you want to make sure that your data input stream is using the socket name which you have defined it in your client. Okay, let's do the output now. On the output stream, you use the class print stream, or you could use the data output stream. They differ in terms of the type of data you can use in writing into the socket and the output. So let's say print stream, I use my print stream class, and again the output is my variable, so I define it. Now I create a new instance of the class print stream. I associate it with the variable output, so it's a new print stream, and I define it over my socket. This is my client socket, and I use get output stream method. So with this here, I can write into the socket. I can put data so that the other side can read it. Or I could use the class data output stream, either print stream or data output stream, and I use the try and catch in the same manner I did it before. Same thing, I use it for the server. The only difference here, I use it on the server socket, which is my server socket, or the server socket here. Again, this is the server socket, the service socket. Okay. I want to stop this video right here. So it's getting 30 minutes, and I will I will explain this guy here and this guy in terms of these two communications between the clients and server. Okay, let me stop right here.